Okay, today's lesson is 5.2 factoring quadratic expressions. So we've learned how to factor out a common factor from a binomial. Today we're going to learn how to factor a quadratic, or better yet, to convert a quadratic in standard form to factored form. So it's a little bit different way of factoring. Key term today is quadratic. So this is something that we're going to explore even deeper, but essentially a quadratic includes a term to the second power. So if you have an expression and the highest power in that expression is the second power, then that expression or equation is a quadratic equation. So we've got two different forms for the quadratic. There's more obviously, but two today that we're going to use. We've got the standard form of the quadratic where you put the highest exponent, the next highest exponent, and constant. And we've got the factored form of the quadratic where we've got x plus r times x plus r2. If we multiply this out using the box method, what we would have after we simplified is our quadratic in standard form. So these two forms are equal to each other. The relationship to these forms is very, very easy to understand. These factors right here, these numbers r1 and r2, when you multiply these numbers together, so let's say R1 is 2, and let's say R2 is 3. When we multiply 2 and 3 together, we get 6, or C. So our two factors, when multiplied together, will give us what the C is in standard form. And then when we add those same two factors together, these two together, they add up to what B is in standard form. And you're going to see that as we go through the examples today. So here we have the example right in factored form, and we've got our quadratic in standard form where we've got x squared plus bx, so b equals 5, and plus 6, and we know that 6 is C. So what we're going to try to figure out is what two numbers multiply to give us 6, but when we add them together give us 5. And that's what these steps are going to cover. So the first step is to figure out the two numbers that multiply to give you 6. And sometimes it's easy to look and say, okay, I know already the two numbers that multiply to 6 and add up to 5, but you'll get numbers eventually where you can't tell right away, so you're going to have to list factors of C, or numbers that multiply together that give you the number that C is. So in this case 6, we know that 6 times 1 gives us 6, we know that 2 times 3 gives us 6, and there's also two more combinations. Negative 6 times a negative 1 would give us a 6, and a negative 2 times a positive negative 2 times a negative 3 would also give us a positive 6. So there's really four combinations here that would give us 6 when we multiply. Now we've got to decide, of these four combinations, which combination would add up to 5? Because now we're trying to find B. We've got the factors of 6. Now we've got to select the correct ones that also add up to 5. So if we add these together, 6 plus 1 equals 7. That's not 5. 2 plus 3 equals 5. Okay, so here we have the numbers that multiply to give us 6 and add to give us 5. So we found the correct factors, 2 and 3. So we can say that R1 equals 2 and R2 equals 3. So now our third step here is to write the factors in factored form. So we've got x, and since this 2 is positive, we can go ahead and say plus 2. And we've got x plus 3. And this is our final answer in factored form. Now, just to check to make sure that we've actually factored it correctly, what we could do is we could set up the box method, and we could go ahead and multiply it to see if it multiplies back to the original quadratic in standard form. So let's go ahead and just try this out in the first example. So we've got our box, we've got x times x is x squared. We've got x times 2 is 2x. we've got x times 3 is 3x, and we've got 3 times 2 is 6. See how that 3 times 2 is 6? And then when we add our like terms here, which is the numbers adding up to b, right, they add up to 5. So we've got x squared plus 5x plus 6. So you can see that when we multiply it out, we get the original quadratic. Alright, let's get into some examples more. So here we have our quadratic in factor form. First thing I'm going to do is I'm going to identify what c and what b are. So I know that b is the number in front of the linear term or the x term. Since there's no number, I know that that number is 1. And c is the constant that is being subtracted in this case, so negative 12. So we need numbers that multiply to give us negative 12, right? So if we set up this box, right, we know that these top box are x's, and we know that this box right here is negative 12. So I'm looking for numbers that multiply to give us negative 12, but then when we add these boxes right here, we'll add up to a positive 1. So I'm just going to start with some factors. Okay, what about negative 12 times 1? Those numbers multiply to a negative 12, but when we add them up, they add up to a negative 11. So this is not the combination that we're looking for. Okay, so let's try different factors. What about negative 6 and positive 2? These numbers multiply to a negative 12, but when we add them up, negative 6 plus 2, they add up to a negative 4. That's not what we're looking for, so let's try some other combinations. Well, what about, what if we made the 2 a negative and we left the 6 as a positive? So what if we said negative 2 times a positive 6? These numbers would multiply to a negative 12, but when we add them up, they add up to a positive 4. So that's not even close to 1. So we may have to try some different numbers as factors. Well, what other combinations multiply to 12? What about negative 4 times a positive 3? These numbers multiply to 12. But when we add them up, negative 4 plus 3, we get a negative 1. But that is very, very close to what we're trying to find. We're just trying to find a positive 1. So if we switch these signs around, then we're going to get the answer that we want. So negative 3 times positive 4. That multiplies to 12, and then when we add it up, negative 3 plus 4, this adds up to a positive 1. So we found the right combination, the combination that multiplies to 12 and adds to 1. So we can go ahead and write our answer in factored form. We've got x, and since this 3 is a negative, we can just say minus 3. And it's a positive 4, so we can say x plus 4. And we now know the rest of this box. Example number 3. So I'm going to go a little bit quicker now that we kind of have an idea. So we know that b is negative 9. And we know that c is 8. So numbers that are going to multiply to 8 but add up to negative 9. Well, I know that the number 9 is larger than 8. So I know that this combination is going to have to include some large numbers when we multiply. So I'm going to start off with a 8 times 1. I know 8 times 1 gives me 8 when I multiply it, and then when I add those together, I get a 9. Now that's very close to what I need. I need a negative 9. So how can I get a positive number when I multiply, but a negative number when I add? Using these numbers, because I know that these numbers are the right combination because they're giving me the value of 9. Well, what if we made them both negative? Like negative 8 times a negative 1. When we multiply these two, we get a positive 8, and then when we add them together, we get a negative 9. So this is the combination here that is our answer. So our factors here are x minus 8, x minus 1. Example number 4, and I want you to make a mental note of this example because this is a special type of example. This example is called a perfect. No, it's not called a perfect square. It's called the difference of perfect squares. And you'll see why I say that after we've completed this example. So you're looking here and you see x squared minus 9, and what you're probably thinking is, where's the b? There's no x term and coefficient in front of it, so we don't even have a b here. So what we can say is that b in this example equals 0 because there's no b, and c equals a negative 9. So in your head you're having to think of what numbers multiply to give us negative 9 but add up to 0? Well, I know that numbers that add up to 0 are always opposite numbers. So what combination of opposite numbers gives us a negative 9? Well, you should be thinking, okay, 3 and negative 3. These numbers multiply to give us a negative 9, and then when we add up 3 and a negative 3, they add up to 0, right? Very, very different than maybe you're thinking, okay, negative 9 and 1, yeah, they multiply to give us a negative 9, but when we add them together, they give us a negative 8, right? So we know that the factors here are positive 3 and negative 3, and that's why we're calling this the difference of perfect squares. So they're almost the same number, but they're just different by sign. So the answer here is x minus 3 and x plus 3. So when the number for c is a perfect square, so like the square root of 9 gives you 3, the square root of 16, so if we had x squared minus 16, this number right here is a perfect square, then the factors are the opposite of that number, the opposite numbers for when you take the square root of c, so negative 4 x plus 4, right? Or let's say you had x squared minus 25, right? 25 is a perfect square. The square root of 25 is 5. So our factors would be x plus 5 and x minus 5. So these are special types of quadratics that are fairly easy to identify because the constant is a perfect square, a number that gives you a perfect number when you take the square root of it. So x plus 6, x minus 6, and we could keep going on and on and on, but hopefully you kind of see the pattern here. Alright, last example for today. So this is also a special type of quadratic, and this type of quadratic, I'll give you the name up front, is called a perfect square. So we had difference of perfect squares, but this is called a perfect square. So if the difference of perfect squares are opposite numbers that are the factors, then obviously perfect squares are going to be the same number. But we'll see that as we go through this example. So we know that b is negative 18, and we know that c is a positive 81. So numbers that multiply to give us a positive 81 are 9 and 9. But when we add up 9 plus 9, we get a positive 18. We need a negative 18, so let's go ahead and change the signs of both of them because we need it to multiply to a positive, so both of them have to be negative. Negative 9 times negative 9 is a positive 81. And when we add up negative 9 plus negative 9, or minus 9, we get a negative 18. So here is our combination. So our square is x minus 9 times x minus 9, and you can see that both of the factors are the same number. So because we have two x minus 9s being multiplied here, we can write this also as x minus 9 squared. And that's why it's a perfect square, because if we took the square root of this, what we would be left with is x minus 9, and we'll get into more square root stuff in later lessons. But there's two ways to write this, so you could choose when you have a perfect square which way you would prefer. Good luck on the problem set.